Assalamu alaikum friends, this is Saeed. Welcome back to our civil engineering YouTube channel. Don't forget to subscribe our YouTube channel for civil engineering videos. Friends, today our topic is lapping for beam. In this topic we will discuss why we provide lapping in beams and how much length is required for beam for lapping, and where is lapping zone, in which area we can provide lapping and which area we cannot provide lapping. So these all things we will discuss today in this video. So why we need lapping? Because the steel reinforcement we coming from the factory is in standard length, which is available in 10 meter, 12 meter length, because we will receive steel from factory in 12 meter length. So in the beams we will need different sizes for bottom bars and top bars also. Suppose this is a diagram of beams and columns. These are the columns. This is column. This is also column, and this is beam. So upon loading on the beam, in the beam some deflection occurs in beam, like this, in this shape. So in beam maximum positive movement occur in the lower portion, positive movement. This is positive bending movement. Due to loading on beam, some bending stresses occur in bottom of the beam, and upper portion in the near the column section, negative movement occurs, negative movement. So this is in the middle portion, positive bending movement. So when we will provide overlap, see in this diagram, so in this area we will not provide overlap. This is steel bar. So in this area we will not provide lapping. We will provide lapping in this area, in bottom reinforcement. This is negative movement, so we will provide lapping in this area. Also here is zero movement, so we will provide lapping here in this side. This is the bottom reinforcement of beam. Also in top reinforcement we have negative bending movement near the supports section of the column. Here also, here is maximum negative bending movement, and in the middle portion there is zero bending movement. So in upper section of the beam we will provide reinforcement here. In this portion we will not provide overlap. In this portion also we will not provide overlap. Here in the middle portion we will provide overlapping in this area. This area we will provide overlapping, because here negative bending moment, here bending moment is 0, minimum bending moment. And in the sports, near the sports, maximum negative moment. That's why we will not provide lapping here. We will provide lapping in the middle area for upper reinforcement, and lower reinforcement we will provide overlapping on the sports, because bending here is less bending moment. So lapping zone, in this diagram we will discuss lapping zone. In bottom reinforcement of beam L by 8, from this side also L by 8. And for top reinforcement, L by 3, L by 3, L by 3. In upper portion we will provide overlap here, and in the bottom portion we will provide overlap in this L by 8 side portion, also in this side. Suppose we have L, length of the beam 16 meter. So 16 divided by 8, 2 meter. So 2 meter from this side to here, 2 meter we will provide overlapping. Also in this side 2 meter from inner side of the sport to the here 2 meter. This is lapping zone. Only we will provide lap here. In this side we will not provide lap. In upper reinforcement L by 3, if we have 16 meter, 16 divided by 3, 5.30 meter. We will, after 5.30 meter, from this side and from the other sides we will provide overlapping in this area. And for positive reinforcement we will provide lapping length will be 50 into D dia of the bar. So if we have dia of bar 20 mm, so lap length will be 50 into 20, 1000 mm. So this lap length will be 1000 mm. And in case of the top reinforcement, lap length will be is equal to 24 into dia of bar. 24, if we have 20 mm diameter of bar, then into 20 it will come 480 millimeter lapping length for top reinforcement. Hope guys understand. If you like video, please subscribe our channel and press bell icon for more updates. Thanks for watching. Allah Hafiz.